In this video, we are going to discuss about quadrature phase shift keying, which is a modification of binary phase shift keying. In binary phase shift keying, we have transmitted bit 0 and bit 1 with 180-degree phase shift. Here what we are doing, we are combining bit 0 and bit 1 and producing its various symbols. When you combine bit 0 and 1, you can combine these four symbols, that is 0, 0, 0, 1, 1, 0 and 1, 1. So instead of now two symbols 0 and 1, now you are transmitting four symbols 0, 0, 0, 1, 1, 0 and 1, 1. In the BPSK, that is binary phase shift keying, the bit duration was TB second because at that time one bit was transmitting. Now one symbol consists of two bits, so that means now our bit duration is 2 TB seconds because it combines two different bits. And the phase shift, as far as BPSK is concerned, the phase shift between 0 and 1 was pi, that is 180 degree. But in QPSK, as we have four symbols, so 360 divided by 4, that is 90. So every symbol will be having 90 degree phase shift. So after every 90 degree phase shift, you will get a different symbol out of this four symbol. So now we will first discuss about QPSK transmitter, and then we will discuss about the QPSK receiver, how QPSK transmitter and receiver works. So here you can see the transmitter. In this transmitter, you are using two D flip-flops which are connected through this toggle flip-flop, one directly and another with a bubble, that is inverted clock. So one clock is given to this through this, and one inverted clock is given to this D flip-flop. Bit sequence BT is given to both the D flip-flops. Now bit duration is TB seconds, so that means every bit is coming after TB seconds. But this D flip-flop is storing the bit for how many duration? For 2 TB seconds. So when first bit enters into this flip-flop, it will stay there for 2 TB second. But after TB second, from the bit sequence, second bit is entered, so it will enter into this D flip-flop. So after 2 TB second, this bit will go to this multiplier, where it is multiplied with this carrier signal A cos omega CT. Now till that time, the second bit was resting here or saved here. Then the third bit will come here. The first bit is already released, so now the third bit will come here. Then the fourth bit will come here. So that means what basically we are doing? We are basically bisecting our bit duration in two halves. One is called as the even half, another is called as the odd half. So in odd half, the first, third, fifth and seventh and so on, these bits will come, and in the even half, the second bit, fourth bit, sixth bit and so on, it will be stored in the second D flip-flop. So even bit will be multiplied with a carrier signal which is A cos omega CT, and odd will be multiplied with its 90 degree phase shifted carrier. If this is cos omega CT, this will be sin omega CT. So this odd bit sequence will be multiplied with sin omega CT. Then both these signals will be added with the help of an adder, and the output of this adder is nothing but the QPSK signal, which is represented by BET cos omega CT plus B naught T sin omega CT. So this is what is transmitted at the receiver. So with the help of this transmitter, we will transmit the QPSK signal. This is what the block diagram, structure and its explanation. I hope it is understood. Now we will see the QPSK receiver. So now understand the concept of QPSK receiver. In this QPSK receiver, from the antenna you are receiving the QPSK signal, and then it is given to this block which is raising this QPSK signal to its fourth power. You must have recall that in BPSK we were using a square law device here, because in BPSK we were having only one carrier, that is cos omega CT. But here we are having two different carrier signals, so that is why we are raising it to its fourth power. After raising it to its fourth power, we will pass it through a band pass filter which is having a frequency 4 omega c. So 4 omega c signal will be passed through this, and then a frequency divider is there which will divide the frequency by 4. That is, if 400 Hz is given to this frequency divider, it will be giving the output as 100 Hz. So these three blocks, as same as in BPSK, is known as carrier recovery circuit because we are recovering the carrier from these three blocks. So what are the carriers which you are recovering? A cos omega ct as well as A sin omega ct. So basically cos omega ct and sin omega ct, both the carriers are recovered with the help of this carrier recovery circuit, and then this QPSK signal is again given to this multiplier. The second input of this multiplier is the carrier which we are extracted from these blocks. So this multiplier will multiply the QPSK signal with its carrier. So suppose QPSK signal is BET cos omega ct plus BOT sin omega ct. It will be multiplied with cos omega ct from this end. So it will be cos square omega ct and sin omega ct cos omega ct. Sin omega ct cos omega ct can become sin 2 omega ct, and this will be BET 1 by cos 2 omega ct by 2 plus BOT 1 by 2 sin 2 omega ct. Now when this is passed through this integrator circuit, this integrator works as a low pass filter. Low pass filter will remove this term as well as this term, and you will get only BET at this end. This BET is having how much bit duration? 2 TB second bit duration. Similarly, in the lower half what will happen? This BET cos omega ct plus BOT sin omega ct will be now multiplied with sin omega ct. The sin omega ct into sin omega ct will become sin square omega ct, and this will become sin omega ct into cos omega ct, which is nothing but this same signal. And here you will get sin square omega ct, which can also be written in the form of 1 minus sin 2 omega ct by 2. So again 2 omega ct sin and this sin 2 omega ct both will be removed by the low pass filter, and you will get only B naught t. This term B naught t. So here you will get B naught t. Again one more thing, this integrator not only removes the high frequency component but also maintain the bit duration of 2 TB second. So it is basically working on two aspects. Now BET is coming from this integrator and B naught t is coming from this integrator or the low pass filter. Now this latch is connected to these two outputs with this sampling switch, which is working at TB second duration. So at first it is connected to this, so you will get the first bit, and then the second bit will come after 2 TB second, whereas this switch after TB second will connect to this output, so you will get the second bit. So the bits which we have divided into two halves, that is even and half, now we are combining it. So the output of latch is nothing but your bit sequence PT. This is how your QPSK receiver work. It is also same as BPSK because the carrier recovery circuit is there also existing, and in both the cases we recover the carrier from the QPSK or BPSK signal itself, so the error is less in phase shift keying techniques or phase shift keying techniques methods. Okay, so I hope from this receiver block diagram as well as the transmitter block diagram you must have understood the functioning of QPSK thoroughly. Even if you have any doubt after this video, you can write it in the comment section. Thank you.